Okay, domain and range. Domain you want to think of as being all the input values, all the values you're allowed to input. Now typically that's going to be X values, and then the range are all the possible output values. So you can think of that as being the Y values for a function. All right, to describe these, we typically want to be able to utilize interval notation. All right, but interval notation requires understanding that if we have like this top statement where we have 5 is less than H is less than or equal to 10. That matches up with the interval notation, parenthesis 5, comma 10, and then close brackets on the right-hand side. So we want to start getting these down, and this can be a problem for some students is matching up that a strict inequality, like a less than, goes along with a parenthesis every single time, whereas a less than or equal to has to go along with a square bracket. And if it's on the right side, it'll look like that. Left side will look like this, and the parenthesis gets switched around if it's on the right-hand side. All right, so as we're kind of looking at this, let's think about if I wanted to graph this. And I'm just focused on that top one. You'll see that the rest of these really work about the same way. So the important values that we have on this graph are going to be at 5 and 10. All right, and interval notation always has to come in number line order. Just like I'm setting up my graph over here, it's going to come in number line order as well. On the left-hand side, we're not allowed to have H equal 5 because it's a strict inequality on this side. So that's not part of our solution set. So to indicate that on a graph, we're going to use an open circle. On the right-hand side, however, H can be either less than or equal to 10. So if it's allowed to equal 10 and still be a true statement. So what we're going to do over on that side is we're going to use a filled in circle at 10. Now H is allowed to be anything in between 5 and 10. So on a graph we would shade everything in between on this number line. All right, and that does correspond with our interval notation as well. More often than not, your answers or solutions are going to be asked for in interval notation when it comes down to it. One other notation I want to go ahead and mention is set builder notation. So for set builder notation, what we do is we start with squiggly brackets. Then we say our variable, H is our variable in this case, just looking at that top inequality, and then we put a vertical line right after that. When we have this vertical line, we are going to say such that. All right, and I'll read this off in a second so we get comfortable with exactly what's going on here. All right, and then from there, what we're going to do is we're going to take our inequality, we're going to cut and paste it after that vertical line. So we say 5 is less than H is less than or equal to 10. Then we finish it up with some more squiggly brackets at the end. All right, so to read this off, I'd read this off as the set of H such that 5 is less than H is less than or equal to 10. The other way you could say it is the set of values H such that 5 is less than H is less than or equal to 10. And that should get us through it. All right, these other ones are very similar. With 5s and 10s, it's just on either end. You have to be careful about open circles or parentheses. I guess I will go ahead and mention the other thing that kind of goes hand in hand is strict inequalities, parentheses, and open circles. The ones that have or equal to's, closed brackets, and closed circles. All right, so kind of categorize these in the exact same place in your memory as you go through them. All right, I am not doing all of those, but let's move down to we've been given a graph, and let's see if we can rewrite this in interval notation, set builder notation, and as an inequality. So it looks to me like we have two separate intervals, like two separate shaded regions. We have one here, and then another one going off to the right-hand side. So the first one, I think we can describe in interval notation, that's between 1 and 3. All right, because we have filled in circles at both ends, we're going to use closed brackets to describe both ends. All right, the other interval that we have over on the right-hand side looks like it begins at 5 and keeps going to the right forever. Because it keeps going to the right forever, that we have that arrow there, we say infinity, kind of this mathematical thought of a number bigger than all the rest of the numbers is over there on the right-hand side. All right. We should not include 5 because we have an open circle this time. and we never include infinity. Now, if our graph had been going off to the left forever, we would say negative infinity is out that direction. The last piece on this interval notation is in between these, we're going to put the union sign. What that means is this interval makes true statement, and this other interval is also a true statement. It's part of our shaded region up here. So either one, like if you pick 2, it doesn't make a true statement in both of them, but either one is still part of our solution set or our interval notation. All right, next up, set builder notation and inequalities. I'm actually going to go ahead and do the inequality first, and then remember we can copy and paste that for set builder notation. All right, so the inequality, let's say x lies in these regions. The first one, x is trapped in between 1 and 3. Now we typically just use less than or equal signs in between these. All right, so in this case, because we had filled in circles up here at both of these sides, we want to have less than or equal to. X is a true statement, or it's part of that graph if it was 1 or if it was 3 or anything in between. The other one on the right hand side looks like it starts at 5, and then x is off to the right hand side of that, but this one's going to get a strict inequality. So we could say in inequality notation, our solution sets can be 1 is less than or equal to x is less than or equal to 3, or 5 is less than x. Finally, set builder notation here in the middle. Let's go ahead and say this is the set, squiggly brackets, of x values such that 1 is less than or equal to x is less than or equal to 3, or 5 is less than x. And then we'll finish it off with the squiggly brackets. All right, hope this helps out. Keep working on them. There are a lot of variations on this, but you got to get down filled in circle, closed brackets, or equal to signs go together. Open circle, parentheses, strict inequality go together as well. All right, hope this helps. Good luck.